Thank you for welcoming me to your analytics summit. It's a pleasure to be here. As I was introduced by Glenn kindly, I'm Rama Akkiraju. I am a CTO for what is called AI operations at IBM and an IBM fellow. So today I'll talk about making AI work for enterprises, and given the short amount of time, I'll specifically distill and share some of the lessons learned from having built AI services and AI infused applications for solving specific business problems, a distillation of that and lessons learned from that from a methodology perspective. So we all hear about AI in our day-to-day lives all the time. We use it every day, either consciously or subconsciously. We use it in our smartphones, in various devices around our homes, in toy robots that our children are playing with, and Roomba type of robots in our homes, phones, name it, and entertainment, Amazon, Netflix, and including self-driving or driver-assisted automated driving cars like the Teslas and others that are coming up. So they're there in our day-to-day lives already, very prominently. In companies as well, AI is being increasingly used for various use cases and scenarios, all the way from process automation to developing virtual assistants, that is chatbots that are starting to answer customer scenarios, to recommender systems that provide various kinds of recommendations, be it in retail or as doctor's assistants to doctors in suggesting treatment plans and options that have worked for patients with similar kinds of illnesses and similar kinds of symptoms and those sort of things, or as recommender systems and decision support systems in legal domains where AI can process large volumes of text and legal documents to help attorneys prepare for cases and those sort of things, or be it in social media monitoring, security systems with image recognition, fingerprinting recognition, and other examples in decision support systems include in college application screening and credit application screening and so on. So in many business cases as well, business use cases, AI is being increasingly implemented and applied, and we are starting to see it more and more. If you look at what are the major opportunities that AI offers for optimizing business processes, we can look at them in the following categories. Be it automation, it's enabling automation in some ways, you can say. Optimization, offering decision support where it is providing all the options but not necessarily making the decisions. Augmenting human intelligence in the case of doctor's assistant or legal assistant, it's about helping unburden doctors and legal folks in processing those large volumes of data, but eventually users, the doctors or legal folks are the ones who are making the decisions. So it's augmenting human intelligence. Personalization, like we looked at in retail, increasingly by analyzing the usage patterns and what they are saying about their sentiments and their preferences and attitudes and such on social media, using that information to really guide the product recommendations or advertising and those sort of things. And more in natural interfaces, right, where speech, natural language based, that is text and images, have become natural interfaces in interacting with computer systems. So these are many different ways in which AI is being applied. And some of the sample analytics I've listed on the right, not necessarily the only set, but in order to enable automation, you could think of using techniques such as classification for optimization. You could think of techniques such as regression for decision support. Things such as causal reasoning, help me explain what happened and provide me causal or correlations and such. For augmenting human intelligence, it could be providing support in terms of doing deep unstructured data-based search, data analysis-based search insights and discovering new insights. And in the case of personalization, it's about deriving one's sentiments and emotions. In the case of supporting natural interfaces to interact with systems, it's about doing speech to text, being able to understand speech that's being spoken by users and understanding the natural language and the intent in the natural language, and being able to understand the objects in an image and so on. So there are many, in order to support the kind of opportunities that are on the left-hand side, there are many AI techniques that are being brought to bear to address these problems. If you look at the building blocks in AI for supporting all of the kinds of use cases that we talked about, be it in consumer domain, business domain, or whatnot, we need the following foundational pieces, right? We need text to speech, speech to text, natural language understanding sort of services that can understand text and detect entities, relationships, keywords, concepts, and those sort of sentiments in them. And we need techniques that can recognize images. We need techniques that can understand people's personality traits and suggest things based on, you know, their personalities and what their proclivities would be, and being able to do the natural language classification to say, what is this particular piece of text saying? Is it about that topic or this topic, and so on. And of course, language translation, because natural language, unstructured data comes in many languages, as many languages as humans speak or business gets done. And we need to be able to understand all of this data that's coming in speech, text, and the captions within images and all that in all the languages. And dialogues, you know, if you want to support additional applications on top of all of this, you need to be able to carry out dialogue with humans and human computer interaction-based systems. So that is important. So there are a set of building blocks that need to be built in order to enable the kind of use cases that we talked about in the previous chart. And these are all services that you may have seen, you may already be using. There are many companies that are starting to build these as foundational services, and they're making them available on cloud. And many companies are starting to consume these services to build business applications they need. For example, if you have ever interacted with an automated chatbot, it is behind the scenes is understanding the natural language. It's classifying the intent associated with what you're typing. It is doing some kind of a dialogue tree management underneath to match that intent with a pre-baked response. Or in the case of a long tail type of a question answer, it is going into some kind of an enterprise knowledge repository and matching the question or the intent with a known set of documents and bringing you a summary of that document in terms of what action you can take to resolve whatever problem you've called with, and is responding back. And if that chatbot is actually speech enabled, it's automatically understanding the speech that you have spoken, converted it into text behind the scenes, and that text got analyzed as the intent behind it and all the, you know, corresponding retrieval of the corresponding response for the question, and converting that speech back to text. The text back to speech to speak back to the user. So there is so much of this happening. And in that one application, chatbot application, we saw how many of these foundational AI services have to come together in order to build such a chatbot. Similarly, you can imagine any kind of an interactive AI-based solution that you may build, you would be relying on one or more of these kind of foundational services. So now I'll talk about it from the perspective of when you build these AI-infused solutions, what is the life cycle process that you go through, and what it means to really make that AI-infused solution perform at the levels that you expect in order to achieve whatever that use case is, be it optimization, be it automation, decision support, and all of the things we talked about. So AI models or AI-infused applications have a life cycle. They are unlike traditional software that we write. For traditional software, you have very specific set of requirements. And you write some test cases, you write the logic, and you test it against that particular set of test cases which are representative of the requirements. And it's a very predictable, for the most part. Every time you write it in one way based on the input, it will always produce the same output. And you test it and you say it's passed it, therefore, once it passes all the test cases, the software is ready to go. But whereas in AI, we are talking about the system learning patterns and making predictions, and the prediction could be right or wrong. It depends on how much of the real world patterns that it has observed. Have we been able to feed the system all of the patterns that occur in real world? And especially if it is a machine learning model, it needs to see enough instances of each of those patterns in order for it to learn the patterns. If it is a rule-based system, somebody has to either codify it explicitly, all of the patterns that may occur, or somebody has to feed enough data for the system to learn those rules automatically. In either case, we are talking about data, we are talking about expertise. For the moment, for the purposes of this talk, let me just kind of continue on with machine learning models. They need a lot of data. The life cycle of data itself is a huge process. Let's take, you are building a chatbot application. Let's take that as an example. And let's say you are building it to specifically address some kind of a frequently asked questions in a particular enterprise domain. That means you have to feed the system enough instances of those intents. What are the kinds of questions that users ask, and what kind of variations do they ask them in? You have to feed it enough for the system to learn to classify those as this particular type of intent. This type of question is related to password, or this type of question is related to not being able to access the system. Whatever the case may be. So there is a lot of data. And if you're talking about speech recognition, we are talking about really getting a lot of audio data corresponding to users who are speaking a specific language with specific accents, and being able to collect all the data, make sure that you're training the model with all of that type of data so that it's able to catch those variations and those intonations, those dialects and all that. So there's a lot of data that needs to there's a lot to data that needs to be done and prepared in order to train the models. Data itself has a life cycle of its own. It takes, how do you acquire it? Where do you acquire it from? How do you clean it? How do you enrich it and annotate it? Where do you store it? How do you analyze it to make sure that you're bringing in representative data and balanced type of data for each label that you may be trying to classify, and so on. Then comes feature preparation. Either you do it using language models that are coming up these days, wherein you feed large amounts of data and they figure out what the features are and prepare some kind of n-dimensional vectors for it, which can be used as features. Or in some cases, you may have to prepare them by tokenizing them and looking at the parts of speech, lemmatizing things, and creating phonetic dictionaries if it is in speech, and so on and so forth. And then, of course, you have to go through the life cycle of what algorithm is the best one to choose, what is the architecture like, what are the parameters that you would expose for tuning, and how do you deal with error, edge case handling, and the training and all that, and the testing and benchmarking, and then finally deploying it and for scale and managing it. And the system will, of course, have to be continuously improved. Otherwise, it becomes a stale model. You take data once, but the data is constantly changing in real world. Your customers are starting to ask newer questions. You have implemented a newer system, but you are still able to answer only the old questions. It doesn't help for the chatbot. It becomes useless after some point if it's not constantly learning the changes that are happening in the environment, and also adapting that to refresh itself and to continuously keep improving. So there is the continuous learning cycle. So the process itself is for any AI model, underlying model that you use, or AI infused application that you build, you have to ensure that it has that method and platform for continuously learning from the environment and improving. So that's kind of just a little bit of background on what is it about AI models. Now let's get into the specifics. What I told you that I'll talk about what does it take to make AI work for companies. Now, when you put any kind of an AI-based solution in place, be it chatbot, be it college application screening AI solution, or an image recognition solution, whatever that may be, a standard set of attributes need to be looked at and very carefully managed. And this is where building traditional software is building AI-based systems, AI-based solutions is so very different from building traditional software-based systems. So let's look at what those are. I have coined this mnemonic called race your facts to make it easy to remember these attributes of an AI model that need to be paid attention to. Each letter stands for a particular attribute. I'm not going to cover them in the exact same order, but I'll mention them in the order. Race, R is for robustness, A is for accuracy, C is for continuous learning, E is for explainability, that's race. Your is just something easy to remember in between. Facts, let's get to that. F for fairness, A for accountability, C for consistency, T for transparency, and S for security. So these are all of the attributes of AI models that anybody who deploys it will immediately have to answer and have to wrestle with. So in the rest of the talk, I intend to talk about what it takes to really make AI work for enterprises. I know we have short amount of time, but let's go through this. Accuracy. It's not enough just to say that, I want to have the best performing 100% accurate AI model. Well, even you can say that you may wish to have that, but it's may or may not be practical to have it. It depends on, what is the problem that you're trying to solve. If you say, I want a speech recognition system that works to recognize any spoken speech by any person on planet Earth in any language, in any dialect, for any intent. Imagine we're talking about general AI solving that, and it's such a humongous problem to make it work. And the amount of effort that's required to get to that level of accuracy for that wider problem is huge, and nobody has the resources to do it. Moreover, it's highly unlikely that somebody is really trying to solve that problem. It's more likely that somebody's trying to solve, I need to build a chatbot for my company. I'm a retail company or an insurance company, or I need to build this chatbot that can take orders in a drive-through setup for a fast food company. So you have a well-defined problem there. So, well, if we take the last example, then, I need to be able to understand speech that is spoken by people related to the menu or the menu options, where there could be background noises, the car engine is running, there could be the window is down, therefore other cars that are driving by and the honks and everything is there. Children might be yelling in the background, dogs might be barking in the background in the car. That is the problem you're solving. You need to be able to have a speech model that can detect those menu options, words, and the speech that is spoken in the context of that, saying, I changed my mind, I don't want that burger anymore, I want this order of sandwich. Or that, I don't want coffee, make that Pepsi, or Diet Coke, whatever, right? So those kind of changes, or that's the language that we are talking about that we want to understand. So what I'm saying in this picture is that there is something called a base model. That is the one thing that we quickly learned, is that if you want to improve your accuracy, understand what problem you're trying to solve. Don't try to solve it for the whole world. A model that understands enough of language, enough in that particular case, is good enough. Now, quickly get to the specific problem that you're trying to solve, the specific industry or the custom problem. In this particular case, the menu is the real focused. My menu for my company is what I care about, right? You don't even have to solve the entire food industry's all food terms problem. So get to that, and then you can take data that pertains to that domain and use that data to train the models and improve it, and focus on improving the accuracy for that, as opposed to solving the general purpose problem. So by narrowing the domain, you can get to higher levels of accuracy and precision, the numbers that you want, with smaller amounts of data. Because typically the larger amount of training data, the better the accuracy would be. Of course, there will be some diminishing returns after some point, but nobody has ever touched that point as in, oh, I have way too much data, therefore, and I'm not improving anymore, therefore I'll stop collecting data at this point. Usually you're never in that situation. You're always, I don't have enough data, I need to still make, you know, a damn good AI model here. What do I do? So there, the quick answer is narrow the problem, really understand what problem you're trying to solve, then you can get to higher levels of accuracy with smaller amounts of data. That's one. Continuous learning. Well, just like we all fell down many times while learning to ride a bike, AI models do make mistakes, and they need to be given chances to learn and improve. And the chances are, you're not just simply saying, okay, just take more time, but along with more time, more iterations, additional new fresh data needs to be supplied to it so that it can learn from its mistakes. And that means somebody has to tell it what mistakes it's making. So how does it know what mistakes it's making? So there are many ways to do it. I know it looks a little cluttered. I'll simplify it and quickly go through it. One way to do it is an AI model makes a prediction, takes some input, makes a prediction. It's either right or wrong. Just look at the green threads for the moment. It took some input, made a prediction. It's either right or wrong. Either a human tells the system that, hey, your intent, somebody said that they want a burger and you recognized it right, that it's a burger order. Good. Thumbs up. But in the other case, it's a, for that burger, you recognized it at some other item. It's wrong, incorrect. So when a user gives initially that kind of feedback, the system can really learn from it and make improvements, if the whole setup is done in such a way that it is able to make improvements automatically. And that's the responsibility of the AI platforms and the vendors who are building the AI models, so that they are able to build in this platform for continuous improvement and lifecycle management. Over time, after giving enough of that feedback, the system may be able to build a model of itself to predict whether it's going to get the prediction right or wrong and start to improve it. So there are some subtleties, technical details we can get into, but suffice to say in this forum, given the amount of time, that it's important to build that kind of continuous improvement, and users have to be part of it. So it's a human in the loop AI systems, because we're not there yet to train models with small amounts of data at the moment. Next, fairness. This is a hot topic. This keeps coming back all the time. If you don't have clarity of purpose, everything, all roads will lead you there. We've heard in popular media, social media, every other month there will be an article in major newspapers that AI models have wrongfully accused somebody of crime, or that AI models have discriminated somebody and they recognized, African legislators' images as chimpanzees. That raises uproar in the media, rightly so. And this keeps coming back because AI models are being built without specific purpose and clarity. If you have clarity of what is it that you want the model to do a good job of, then you should do a damn good job of first collecting all the test data, that similar to how when you write software, you want to build the test cases first, build the test data sets first, and ensure that when you build models, when the data scientists build those models, that they are built to really do good job in prediction to the levels that are expected. Otherwise, all roads will lead you there. The data scientist will build your data model and you will deploy it, only to realize that it exposes all kinds of vulnerabilities. That's because you haven't set a goal. If you set a goal correctly, then when it is tested, when the data scientist builds the model, when it is tested, you will know whether it is performing to the level expected or not. For example, you can't just, the same image recognition model that can detect human faces may not work very well for detecting rusty bolts. If your domain is, say, in retail or in oil pipeline industry, where you are applying these image recognition to identify rusty bolts to see when to do proactive and proactive maintenance, then you got to build a model that specifically is really good at predicting rusty bolts. Similarly, if your job, if your AI model is going to be used for classifying parliamentarians for whatever reason, then it should be trained on who are the representatives, what are their images like. Give enough of each kind of a of individual or person's images to the system and make sure that it has enough representation, right? So the goal has to be clear, and you can't be trying to solve everything under the sun. And that's the key point that I'll keep making. This is a hard learned lesson. So it sounds very simple and easy and very obvious in hindsight when you hear it. But when you put it to practice, I have seen time and again companies and managers, leaders fall into this trap of not having clarity on what is the purpose of that AI model. What is the specific scope for which you are putting it to use? Next couple of points quickly: transparency and explainability. If you put in an AI model and it says the answer is yes or no, your application is rejected, or your college applications in the screening, if it is making the decision, it's rejected. How would you know whether it got it right or wrong? And in many domains, there could be a lot of transparency requirements that force you to actually explain how the model arrived at the answer that it arrived at. So it really depends on the domain and use case. Again, it cannot be a blanket solution. By design, AI models would be much better off to be more transparent and be explainable rather than black box systems. However, there is another school of thought. I'll just present it out there for you to think about. We go to a doctor and we say, I have, this particular condition, stomach problem, this and that. Doctor will give you a medicine. Do you exactly ask, how does it work? How does it break down in my stomach into different compounds? How does it interact with my enzymes in my stomach? Do you ask all those questions? You trust because it's been tested enough. So maybe when AI systems get really good to such level, in some domains, maybe you don't question it so much. But in other domains, it really, wherever it touches humans' physical well-being, financial well-being, and mental well-being, there has to be a lot of transparency and explainability. Black box systems are a big no-no. But whereas in social media monitoring, what if the model got it wrong and gave you a wrong prediction of a recommendation of a movie or a particular product? What's the worst thing that will happen? You say, well, it's an irrelevant recommendation. You move on. It doesn't impact your life that much, other than a few minutes of time wasted. So it depends on the use case where you need how much transparency. Consistently improving is important. The only thing I would say about that is that when you're building statistical models, you can regress on some data sets or some specific scenarios, and that may or may not be acceptable in some domains. Users may get very frustrated saying, I already corrected it, but it unlearned that and learned something else this time. But if it keeps randomly learning and unlearning as a statistical model, it can get very dizzying and disorienting to the users who are working with it or giving feedback. So in real world, we face all those situations. And so we have to be really mindful of what algorithms we use and how do we take the user feedback and incorporate it in a way that the models honor it to the extent possible every time and not losing it. And so that's the last mile problem, we call it. We can build a good statistical model based on deep learning, neural networks, whatnot. But when user starts giving feedback, you have to somehow make sure that that feedback is being taken into account and not getting lost in, as a number in large amount of training data samples, labeled data that you have. So the last mile, you may have to use some other techniques, could be rules, could be something else to solve that problem. So you are taking user feedback seriously. You don't want the models to keep drifting. That is, they take any kind of data and keep going in whichever direction. That sometimes users could be manipulating the system by sending it different kinds of data just to take it in that direction, because you take that data that's arriving fresh and start to retrain the model, and you don't want that. And this happens, when there is external forces that you don't control, or sometimes naturally that data is changing and the model is drifting, and you want to make sure it is still aligned with the purpose and the goal of what it was originally built for. The models need to be robust, as in, people can do adversarial attacks on it, and we're starting to see it all the time in security scenarios and such. It can be all models can be manipulated. For example, what might look as a dishwasher, depending on the angle. It may look like a washer, or it may look like a loudspeaker, or something else. So it's better that we prepare the model by feeding it these adversarial samples in the first place, so that it's more robust and is able to withstand those kind of attacks. And there are many techniques that are being presented and in papers in the academic circles and in the industry that enable AI models to get to that. So I'll sum it up by saying, accuracy is important, but don't get bogged down on accuracy alone in the first iteration. First, focus on what problem you are trying to solve. And even if you narrow your domain, you can customize your AI models to get to your target accuracy, if not in the first iteration, over time. And by over time, I mean AI models and platforms have to be continuously learning. That is, they need to be enabled with the ability to take user feedback and fresh data and keep continuously learning and improving, so that the models stay fresh and relevant. Fairness is of course extremely important. Set your goals accordingly and start with test cases first. And if there are any biases that you have in terms of how much data you are able to collect or not able to collect, declare it ahead of time. It's like the nutrition labels. You can see how many calories, how much sugars, how many carbohydrates you're getting, and you can decide whether you want to eat that particular energy bar or not. Similarly, if users know what data it's trained with and how it performs on different test data sets, and you make that available openly to your customers, they can decide whether it's the right thing or not. At least they know what they got into, and they cannot blame you afterwards that this is not the right model. Transparency is a huge concern in areas where it affects humans' health, physical well-being, and financial well-being. And you may have to actually compromise and select the right kind of algorithms to ensure that there is enough explainability and transparency. Consistency is important. You want to learn and improve consistently, not keep on regressing and going back and ignoring user feedback. And there are options, whether you use machine learning or models all the time, or rules to bridge the last mile, or a combinations. And it's no longer this versus that, it's really a combination. Accountability in terms of how you capture the data, what data you trained it with, how you maintain the lineage of everything that went into that model, so you're able to explain and at any time are ready for audit, and also ensure that the models are not drifting from what the original intent of the model was. Of course, robustness is extremely important. I didn't talk much about security today, but security, of course, the robustness and the adversarial, preparing the model for adversarial attacks plays into that security topic as well. So let me conclude there. I know we're out of time. I'll summarize by saying that in order to make AI work for enterprises, a number of concerns have to be carefully paid attention to. And today I talked about a number of them that can be easily remembered with a mnemonic called Raise Your Facts. And what those are listed on the sheet here. And we talked with a few examples on what mitigation strategies or suggestions we have to improve or to achieve those, make sure that your models are paying attention to these attributes, so you're able to deploy models not only successfully, but also to manage them in the long run successfully. Thank you very much.